Okay, this is the video of Mr. Shanebeck going through the review. We'll see how far we get before I have to stop, but I'll just talk you through how to answer some of these and hopefully give you some help. So just the fill in the blank is just kind of general information on the unit and the concepts we learned overall. We'll quickly go through these. So it says the electrons in an atom's outermost shell are called its valence electrons. Sodium wants to lose one electron to become isoelectric neon. That just means that it has the same electron configuration as neon. It has the same amount of electrons as neon. When magnesium gets the same electron configuration of neon, it has a +2 charge, because magnesium will lose 2 electrons to turn into neon's configuration. A single covalent bond consists of 2 shared electrons. The octet rule says that most atoms want 8 in their outermost shell. Ionic bonds is ways atoms get the same configuration as noble gases by gaining or losing electrons. In covalent bonding, atoms share. Atoms in group 15 will lose. They will gain 3 electrons to get a -3 charge. So gaining electrons gives you a negative charge because electrons are negative. Molecules with 5 atoms, like CH4, will have a tetrahedral shape. Vesper stands for valence. Valence shell electron pair repulsion theory. Helium is the only noble gas with 2 valence. Ionic compounds are made up of blank, which are very large structures, alternating positive and negative ions. I think this should be cations, anions, or you could just say ions. When an atom loses electrons, it gets a positive charge. When nitrogen bonds covalently, it will make a total of 3 bonds, and that's because nitrogen, if you look at its Lewis structure, it has 3 electrons that are available for bonding, so that's why it forms 3 bonds. Ionic compounds will not conduct an electric current in the solid state. Metals are malleable. Blank is the only element in group 1 to bond covalently, so that's hydrogen. The difference between trigonal planar and pyramid shapes is that the pyramid shape has an unshared pair. Double covalent consists of 4 shared electrons. 2 types of bonds are going to be ionic and covalent. And then finally, in a blank, the covalent bonds are shared unequally. This would be polar. This polar means opposite, so you have 2 atoms that have opposite electronegativities. There's a difference that exists between them, and you get one that holds the bonding electrons more closely to it, so that you form a polar bond. Okay. Electron dot structure for potassium. It's just going to be a single valence. It's going to want to lose 1 electron to turn into a noble gas configuration. And then the charge, since it's losing 1, it's going to be a +1 charge. The element nitrogen, you're going to have 5 valence. So the dot structure looks like this. How many electrons will it gain or lose? Well, if it has 5, it's going to want to gain 3 electrons to get to 8. It's the shorter path than losing all 5. And then the charge that it forms when it gains or loses those electrons is -3. Okay, 4 and 5 were tough ones. So it says if aluminum and oxygen bonded together, what would the formula be for the compound that they would form? So first let's look at aluminum. It has a +3 charge, oxygen's -2. Since it's ionic, you crisscross those charges. The formula would be Al2O3. And it says use electron dot structures to show how this would happen. This is referring more to your dots and arrows. This is essentially asking for the Lewis dot structure. Now I can draw in 3 oxygens and 2 aluminums because I know the formula from doing the crisscross. So then you're just adding in your electrons to those open spaces. Oop.
So many cute kids, right?
All right. And there you have it. To show it with brackets, aluminum's not going to have any dots on it because it lost all of its dots, so you'll draw it without any electron dots. And an oxygen has gained enough to have 8. And then you want to write down how many you have. So you have 2 aluminums, 3 oxygens. Ultimately on the test, this is what I really just need to see right here, is this guy. But if you want to show the arrows, it's totally fine. All right, number 5, magnesium and phosphate bonded together. What would the formula be for the compound that they would form? So what I would do for this one is establish charges. Magnesium +2, phosphate -3. So you crisscross your charges. Your formula is Mg3PO4 parentheses 2. Oh gosh, that 2 should be down there. Okay, now drawing the electron, it says use electron dot structures to show how this would happen. It's just essentially asking for the Lewis dot. What I would do is isolate the PO4 with the charge, and you draw this as you know it for your Lewis rules for covalent structures. So that includes finding total valence to start. So oxygen is 6, phosphorus is 5. I have 3 electrons. So 6 times 4 is 24. 24 plus 5 is 29, and then the 3 makes it 32. So that's your standard tetrahedral shape number. So phosphorus. We're going to do the 3D structure right off the bat because it's good to do that if you know what it is. Give everybody 8. Okay, I'm going to put it in brackets because it has that -3 charge. And then I'm going to look at the formula and see that there's 2 phosphates. So I'm going to put a 2 in front. Okay, now the magnesium has a +2 charge. In the process of becoming magnesium +2, it's going to give up all of its electrons, so I don't draw it with any dots on it. And I have 3 magnesiums. So that's what I need to see for this type of structures right here. You don't have to do the arrows because sometimes the arrows on this type of problem make it more confusing. You can just go right to the brackets. This is for an ionic structure where you have a polyatomic anion and you're asked to draw the Lewis dot structure. All right, part 3. Oh, I'm going to pause it here because part 3 is going to become its own thing.